Okay, this is lesson 4, review of arithmetic, and in order to complete this, we will need our 4th lesson, the 6-page packet. Now, I promise it's really not as long as it originally seems. Okay, let's start with some of the numbers that we will use during this course. A big group of numbers is the natural or the counting numbers, and those are the ones that whenever we count, we use. So like 1, 2, 3, 4, 5. And they're denoted with this fancy looking letter N that looks just like this. And that's the symbol for the natural numbers. The real numbers are any number that doesn't have a repeating or that does have a repeating or terminating decimal. That's a number that has a definite ending to it. For instance, pi is not real because the decimal point goes on and on and on. The decimals go on and on forever. Some real numbers are numbers like -7, even 1/2. 0 is a real number, or something like 4.8579. Notice that the number stops right here at the 9. We use this fancy looking R to designate real numbers. Okay, let's talk about numbers positions on number lines. We have a number line right here. Notice that we have a list of numbers. 2 numbers are positive, 2 numbers are negative, and then we have a 0. I'm going to put 0 right here in the middle. Okay, and then just to the left over here, where all the negative numbers would be, we have -2/3, which is definitely closer to 0 than, say, -2, which is on our list. Then over here on the right, where the positive numbers are, we'll have positive 0.5 and positive 4. And realize that as the numbers progress to the right, the numbers become larger in value. And that's very easy to see right here on our number line. The last little idea we need to talk about just our numbers and our review of how numbers work are pairs of numbers such as -2 and 2 or -5 and 5 are said to be opposites. Opposite numbers are equidistant from each other on the number line. So if I draw a new number line like this, and I put -7 down here, and I put +7 up here, this distance from -7 to 0 is 7 units. Just like this distance here is also 7 units. Notice how this distance has to be the same as that distance. Okay? Let's go to page 2. Now, in a few lessons ago, we learned how to add and subtract fractions. Now we're going to multiply and divide them. I think multiplying fractions is one of the easiest things we will do this year, and here's why. The way you multiply fractions, you just multiply straight across the top and then straight across the bottom. So watch this. 3 times 6, 18. 4 times 7, 28. This is our non-reduced answer. You just multiply straight across the bottom, straight across the top. Now, of course, we could reduce this by 2 and get 9 over 14 as our complete correct final answer. And that's something you can plug into the calculator and use the ABC button to reduce also. Now, number 2, notice that we encounter 7/16 times 3, but there's nothing in the bottom of the 3. Well, what we're allowed to do is put a 1 down here, and that makes our multiplication a little bit easier. So we have 7 times 3 across the top, that's 21. And then 16 times 1, which is 16 in the bottom. 21 and 16 don't share any common factors, so that is our final answer. In number 3, we have 4 times 4 across the top, which leaves us with 16, and then 5 times 3, which is 15. And again, 16 and 15 share no common factors, so that is our final answer. Now, in number 4, notice that we encounter a mixed number. It is impossible to multiply a fraction times a mixed number. It is absolutely impossible, and you will get the wrong answer if you try to do this. That's why I showed you in the previous lessons to always change these to improper fractions. So really what this is 5 halves times, now remember, bottom times the front, add the top, back over top of the bottom. 7 times 2 is 14. 14 plus 1 is 15 over 7. Now we're ready to multiply. 5 times 15 across the top is 75. 2 times 7 across the bottom is 14. And those do not share any common factors. So that is our reduced answer. Okay? Now, division is really similar to multiplication in that we are going to multiply across the top and across the bottom. Now, you might be thinking, well, if it's division, why are we multiplying? Well, we're going to employ a process called copy, change, flip. Copy the first fraction, change this division sign to multiplication, and then flip this second fraction upside down. We're going to use what's called the reciprocal of that second fraction. So instead of 7/5, it's now 5/7. And since we changed this fraction upside down, we're allowed to change division and multiplication. We have 4 times 5 across the top, and now the process is exactly the same as what we did up here. 3 times 7 is 21. That is our final reduced answer. Okay, let's try number 2. Remember, copy the first fraction, change division to multiplication, flip the second fraction upside down. And now we have 5 times 7, which is 35, over 14. Now, notice how 7 and 7 were on diagonals here. So since I was multiplying the top and the bottom by a 7, obviously our final fraction is going to share the common factor of 7 in the top and the bottom. So if I divide 35 by 7, I get 5, and 14 divided by 7 is 2. And let's make a little note, maybe divide by 7, divide by 7. 5 halves is our reduced correct answer. More on these diagonals on the next page, okay? Just keep that in the back of your mind for now. Okay, just as it was impossible to multiply by a mixed number up here, it's impossible to divide mixed numbers. So we need to change these. 5 times 2 is 10, plus 4 is 14 over 5. Divided by 3 times 1 is 3, plus 2 is 5, 5/3. Now we can do copy, change, flip. 14 over 5 times 3 over 5. Okay, 14 times 3 is 42, and 5 times 5 is 25. No common factors here, so we can go ahead and box this in. This is our final answer. Okay? All right, let's go look at cross cancellation on the next page. Now, these are multiplication problems up here on the top, and notice in number 1 that 7 and 21 share a common factor of 7. So what you might say is, how many times does 7 go into 21? Well, 7 goes into 21 3 times. So I get rid of the 21, I turn it into a 3. Likewise down here, I get rid of the 7, I turn it into a 1. Because 7 went into 21 3 times. So if I divide this and this by 7, I end up with a 1 and a 3. Same thing happens up here. How many times does 4 go into 20? Well, 4 goes into 25 times. 4 divides by 4 1 time. So look what happened. Instead of trying to do 4 times 21 in my head and 7 times 20 in my head, I'm now down to 1 times 3, which is 3, and 1 times 5, which is 5. Whenever you cross cancel, you take away the reducing at the end also. That's what makes this so nice and easy. Okay, I will leave this one for you guys to try. Let's try number 3 together. Remember, it's a copy, change, flip. 2 7s times 21 over 8. Now notice the common factors here. 7 goes into 21 3 times, and 2 goes into 8 4 times. Now instead of trying to do 2 times 21, it's now just 1 times 3. And instead of 7 times 8, it's now just 1 times 4. And our 3/4 answer is already reduced and ready to be our correct answer. Try number 4 on your own and move to the next video for the rest of the lesson.